Let's look at a permutation example where we have repeated elements. I talked about this earlier when we were doing the Scrabble example, but let's kind of look at a almost exactly the same example, and we'll note the difference here. It says in the game Scrabble, a player pulls the following 7 letters: EORRTTU. It says how many different 4-letter arrangements could be made, how many different 7-letter arrangements could be made. So notice that it's almost exactly the same type of question. But notice that I have R is repeated twice and T is repeated twice. So as we discussed before when we were going through the Scrabble example, it should be a permutation example because I'm taking each of those, um, I'm taking all the letters and the order matters, right? Because if I'm developing a word or an arrangement, order is important, meaning it's a permutation, not a combination. And again, the question actually states arrangements, which implies that the order matters. But let's go ahead and read this little box from the book. It says, the number of distinguishable permutations of n objects such that n1 are of one type, n2 are of a second type, and nk are of the kth type, where they all add up to n, is the following: n factorial divided by n1 factorial, n2 factorial, and so on. Basically, let's focus on the 7-letter arrangements to start with. Because it's actually the simpler of the problems, even though it seems like it's harder. But basically, if we're just trying to apply the formula, well, what it says to do is I'm going to take 7 factorial on top, which is just the total number of objects, and divide it by how many objects are of each type. So notice that I have 5 types of letters. E, there's only one of. So I could think of that as being over 1 factorial. O is 1 factorial. There's only one of those. R is 2 factorial. T is 2 factorial. And U is just 1 factorial. And really, one thing that you could remember is that if there's no duplicates, I don't really need to divide by that. And sort of like when we were doing the original example, if there's no duplication, it's just 7 factorial, there's no change. But when there is duplication, all that means is that one of the words, there's kind of some overlap. So if I'm thinking about the math behind this formula, this would be 7 factorial divided by 4, because 2 factorial is just 2. 2 times 2 is 4. Or basically the implication is that there are 4 overlapping words in this chain. But if I was to think about that, like say for example, I was to look at one permutation of these letters, torture, also random, not predetermined, but that would be one of the permutations, right? In 7 factorial, if I just randomly arrange these letters, there should be 7 factorial arrangements of those letters, which we did a minute ago, but I already forgot the number, is 5,040 total things. But basically, here's why that's not the right answer. It's because technically that's counting every order as different, and technically, torture is the same whether or not I flip the t's around. Now, technically, that's kind of like this is another like detail. Is that the same as if the first T was drawn, not the second T? But based on the fact that some of them are duplicated, yes, those should be the same arrangement really. And since R is duplicated as well, there's technically, like if I was thinking about this as T1, T2, and R1, R2, this net calculation of 50/40 is giving me every unique permutation, but there are some overlapping duplicates because if I switch T1 and T2, and leave R1 and R2, or if I switch T1 and switch R2, or if I was to do T1 R2 and T2 R1. Notice that technically there are 4 different ways that I could arrange torture using those T's and R's. Technically, those would all be unique permutations, but really they're not because T and R are interchangeable. But notice that's why we divide by 4, because there's 4 duplicates. And again, what I just recommend is try to use the formula, but I'm trying to give you some sense about why the formula is different and why it makes sense. But anyways, if I take 50/40 and divide by 4, that should compensate for the duplicate words, which would be 1,260 7-letter arrangements. And with 4-letter arrangements, you could do a very similar process where you take that total number of permutations of those objects and compensate, but it's a little bit more complicated.